October 13th, 1943, 8,000 meters above the industrial heartland of Germany, squadron leader William Thompson adjusted his oxygen mask and peered through the plexiglass canopy of his B-17 Flying Fortress. Below him, the sprawling factories of Schweinfurt stretched like mechanical arteries feeding the German war machine, their smokestacks piercing the autumn sky like iron fingers. The German commanders that morning believed their intelligence reports were accurate, that Allied production was strained to its breaking point, and that each aircraft lost would be irreplaceable. Before we dive into this story, make sure to subscribe to the channel and tell me in the comments where you're watching from. It really helps support the channel. What they were about to witness would shatter every assumption they held about American industrial capacity and reveal a truth so overwhelming that it would fundamentally change how the German High Command viewed the remainder of the conflict. The morning briefing at 8th Air Force Headquarters in England had been routine, at least by the standards of 1943 strategic bombing operations. Colonel James Patterson, operations officer for the 306th Bombardment Group, had outlined the mission parameters to crews who had seen too many friends fail to return from similar runs over German territory. The target was the Vereinigte Kugellagerfabriken ball-bearing plant complex, a facility German intelligence considered absolutely critical to their war production. What made this mission different was not its objective, but rather the unprecedented scale of aircraft being committed to a single operation. Thompson's aircraft, christened Memphis Belle II by her crew, was one of 291 B-17 bombers assigned to the mission that day. Each aircraft carried 10 crew members and approximately 4,000 pounds of high-explosive ordnance. The mathematical reality was staggering. Nearly 3,000 American airmen flying in a formation that stretched across 12 miles of German airspace, representing an investment of over $40 million in aircraft alone. For the German defenders, scrambling to intercept this aerial armada, the numbers seemed impossible. Their own production facilities, operating at maximum capacity, could barely produce 30 aircraft per month across all types. Oberst Friedrich Kellner, commander of Jagdgeschwader 11, based near Munich, received the first radar contacts at 0900 hours local time. His communications officer, Hauptmann Ernst Weber, handed him the preliminary report with hands that trembled slightly despite his 4 years of combat experience. The scope signatures suggested a formation larger than anything previously recorded over German territory. Weber had double-checked the readings 3 times before bringing them to his commander's attention, certain that the equipment was malfunctioning. Kellner studied the intelligence summary that had been circulating among German fighter commands for months. According to their best estimates, American aircraft production peaked at approximately 800 heavy bombers annually, with current losses over Europe approaching 15% per mission. The mathematics were reassuring to German strategic planners. Sustained operations at this scale would exhaust American reserves within months. The industrial capacity of the United States, while impressive, surely could not match the focused efficiency of German engineering and production methods. The reality approaching German airspace that morning told a different story entirely. Thompson's squadron alone represented more aircraft than German intelligence believed the Americans could afford to lose in 6 months of operations. Behind his formation, stretching back toward the English Channel, flew an endless procession of 4-engine bombers, each one representing the output of American factories that German planners had vastly underestimated. Technical Sergeant Robert Mitchell, ball turret gunner aboard Thompson's aircraft, had been tracking German fighter formations for the past 20 minutes as they assembled for what promised to be a massive interception attempt. Through his Sperry turret's optical sight, he counted at least 60 Messerschmitt Bf-109 fighters climbing to altitude, joined by an equal number of Focke-Wulf 190 aircraft from bases across southern Germany. The German response was formidable, representing nearly every operational fighter in the region. Yet Mitchell couldn't shake the feeling that they seemed somehow inadequate against the sheer mass of American bombers approaching their targets. What Mitchell was observing represented the culmination of a strategic miscalculation that had been building since America's entry into the conflict. German economic analysts working with incomplete intelligence and their own cultural assumptions about American industrial priorities, had systematically underestimated the production potential of a fully mobilized democratic economy. Their calculations assumed that American workers, lacking the ideological motivation of their German counterparts, would never achieve the productivity levels necessary for sustained long-range bombing operations. The Boeing aircraft factories in Seattle were, at that moment, completing 4 B-17 bombers every day, operating around the clock with 3 shifts of workers who had transformed from peacetime automotive and appliance manufacturers into precision aircraft assemblers. The consolidated plant in San Diego was matching that output with B-24 Liberators, while Douglas facilities in Long Beach contributed additional aircraft to the growing armada. Combined production exceeded 15 heavy bombers daily, a figure that German intelligence considered physically impossible, given their understanding of American manufacturing capabilities. Captain Hans Möller, a Luftwaffe intelligence officer stationed at the Reich Air Ministry in Berlin, had spent months analyzing captured American technical manuals and interrogating prisoner crews about their aircraft production systems. His reports consistently emphasized what he perceived as American manufacturing inefficiencies: the use of civilian contractors, the lack of centralized control, and the apparent waste inherent in competitive production between multiple manufacturers. Möller's analysis concluded that American production would peak at current levels and decline as raw material shortages and worker fatigue degraded efficiency. The formation approaching Schweinfurt that morning represented the complete refutation of Möller's assessment. Each aircraft had been manufactured using production techniques that German observers found incomprehensible. Standardized components manufactured by hundreds of subcontractors, assembly line methods borrowed from automotive production, and quality control systems that relied on statistical sampling rather than individual inspection. The American approach seemed chaotic and wasteful to German engineers trained in precision manufacturing, yet it was producing aircraft faster than any system in history. Lieutenant Heinrich Richter, piloting his Messerschmitt 109 Gustav toward the incoming bomber stream, felt the familiar mix of anticipation and dread that preceded major air engagements. His aircraft was one of only 6 operational fighters remaining in his squadron after 3 months of intensive operations against increasingly large American formations. Each engagement seemed to bring more enemy aircraft, while his own unit's strength steadily diminished through combat losses and mechanical failures. Richter's personal experience reflected broader trends within the Luftwaffe that senior commanders were reluctant to acknowledge. Despite claims of production increases, replacement aircraft arrived slowly and often with undertrained pilots. Meanwhile, American formations grew larger and more frequent, suggesting access to resources that German strategic planners insisted were impossible. The mathematical progression was becoming undeniable. American losses, while significant, were being replaced faster than German defenders could inflict them. The industrial statistics underlying this disparity were staggering in their implications for the conflict's ultimate outcome. American aluminum production in 1943 exceeded 600,000 tons annually, compared to Germany's peak output of 200,000 tons. Steel production ratios were even more dramatic. American mills produced over 80 million tons, while German facilities managed less than 30 million tons under optimal conditions. These raw material advantages translated directly into aircraft production capacity that German planners had consistently underestimated. Staff Sergeant Maria Hoffmann, a radio operator at Luftwaffe headquarters near Berlin, monitored communications from fighter units engaging the incoming American formation. The radio chatter revealed a level of concern among experienced pilots that was unusual even by recent standards. Squadron leaders were reporting bomber formations extending beyond visual range, with escort fighter coverage that seemed to include more aircraft than intelligence estimates suggested the Americans possessed in their entire European inventory. What Hoffmann was hearing reflected the cumulative impact of American industrial mobilization that had been building momentum for over 2 years. The Packard Motor Company alone was producing more aircraft engines monthly than the entire German aero engine industry, while Wright Aeronautical's production exceeded German capacity by a factor of 3. American subcontractors, including companies that had never manufactured military equipment before the conflict, were contributing components and materials at rates that made sustained large-scale operations possible. The philosophical differences underlying these production disparities extended beyond mere industrial capacity. German military doctrine emphasized quality over quantity, precision engineering over mass production, and elite units over large formations. This approach had achieved remarkable early successes, but it was fundamentally incompatible with the requirements of sustained strategic bombing campaigns. American doctrine, by contrast, accepted higher individual aircraft losses in exchange for overwhelming numerical superiority that made defensive success impossible. Obergefreiter Wolfgang Krauss, a radar operator stationed near the Swiss border, watched his scope display become cluttered with returns that exceeded the equipment's designed tracking capacity. The formation appeared to consist of multiple groups flying in close coordination, each group containing more aircraft than his sector typically observed in an entire week. Krauss had been tracking American operations for 8 months, documenting a steady increase in formation sizes that suggested either improved pilot training or dramatically expanded aircraft availability. The reality was both. American pilot training programs were graduating crews faster than German schools could replace losses, while aircraft production had reached levels that seemed fantastical to European observers. The Primary Flying Training Command was processing over 100,000 aircrew annually through facilities that had been constructed in less than 2 years. These training programs operated with aircraft that German planners would have considered frontline equipment, using fuel allotments that exceeded total German aviation gasoline production. Thompson, monitoring radio communications from his pilot's seat, could hear German controllers attempting to coordinate defensive responses to his formation's approach. The radio traffic suggested confusion and uncertainty among ground commanders who seemed unprepared for the scale of the incoming raid. His own mission briefing had indicated that this operation represented only a fraction of American strategic bombing capacity, with similar formations being prepared for operations against targets throughout German-occupied territory. The strategic implications of this capability were becoming apparent to German commanders who had access to comprehensive intelligence reports. General der Flieger Adolf Galland, commander of German fighter forces, had been receiving increasingly pessimistic assessments from frontline units about their ability to sustain effective resistance against American daylight bombing operations. Each successful interception seemed to result in the appearance of even larger formations within days, suggesting access to reserves that German calculations indicated should not exist. Feldwebel Klaus Weber, an aircraft maintenance chief at a forward fighter base, had documented the declining availability rates of his squadron's aircraft as replacement parts became increasingly difficult to obtain. His Messerschmitt 109s required components manufactured at facilities that were themselves targets of American bombing operations, creating a logistical spiral that seemed impossible to resolve. Meanwhile, intelligence reports indicated that American aircraft were being repaired and returned to service at rates that suggested unlimited access to spare components and materials. The maintenance differential reflected broader disparities in industrial organization and resource allocation. American maintenance facilities operated with standardized procedures and interchangeable components that allowed rapid repairs and modifications. German systems, while technologically sophisticated, required specialized components and skilled technicians whose availability was becoming increasingly constrained. The result was declining aircraft availability despite steady production of new machines. As Thompson's formation approached its initial point for the bombing run, German fighters began their attack runs with a coordination and skill that reflected years of combat experience. Richter's squadron, diving from altitude toward the bomber stream, demonstrated the tactical excellence that had made the Luftwaffe legendary in the early years of the conflict. Their attack patterns were textbook perfect, executed with precision that showcased German pilot training and aircraft performance capabilities. Yet even as German fighters achieved tactical success against individual bombers, the strategic picture remained unchanged. For every American aircraft forced to leave formation, 10 more continued toward their targets. The mathematical reality was becoming inescapable. German defensive success required impossible efficiency ratios to prevent mission completion. The American approach sacrificed individual aircraft to ensure overall mission success, a trade-off that German doctrine found both wasteful and incomprehensible. Captain James Riley, navigator aboard a B-17 in Thompson's formation, calculated bombing approach vectors while monitoring German fighter attacks around his aircraft. His training at navigation school in Texas had emphasized the industrial philosophy underlying American strategic bombing. Accept tactical losses to achieve strategic objectives through sustained operations that enemy production could not match. The approach required aircraft availability that German planners considered impossible, yet Riley's presence over German territory proved its viability. The bomber stream's approach to Schweinfurt represented the culmination of industrial mobilization that had transformed American society in ways that European observers struggled to comprehend. Entire cities had been constructed around aircraft production facilities, with populations approaching 100,000 workers dedicated to manufacturing bombers and fighters. These communities operated with efficiency levels that German industrial experts considered theoretically impossible, given American labor practices and management structures. Lieutenant Franz Schneider, flying his second combat mission in a newly delivered Focke-Wulf 190, found himself struggling to maintain formation integrity as American escort fighters engaged his squadron during their approach to the bomber stream. The American fighters demonstrated aggressive tactics and numerical superiority that seemed to reflect unlimited replacement capacity. Each engagement resulted in German losses that were difficult to replace, while American formations appeared to grow larger with each successive mission. What Schneider was experiencing reflected the mathematical inevitability of industrial warfare between economies of vastly different scales. American fighter production exceeded 2,000 aircraft monthly by late 1943, while German production struggled to maintain half that rate, despite operating at maximum theoretical capacity. The disparity was compounded by training rates that favored American replacement pilot availability by factors approaching 10-to-1 in critical specialties. The ball-bearing factories below Thompson's formation represented targets chosen specifically for their strategic importance to German war production. American planners had identified these facilities as bottlenecks whose disruption would cascade throughout German manufacturing systems, yet the irony was becoming apparent. The aircraft delivering this disruption represented industrial capacity that German systems could never match, regardless of specific target vulnerabilities. Oberst Kellner, coordinating defensive operations from his command post, received reports that confirmed his worst fears about the scale of American operations. The formation approaching his sector represented more aircraft than his intelligence staff believed existed in the entire American-European inventory. Either German estimates were catastrophically wrong, or American production had achieved levels that exceeded all previous calculations by impossible margins. The truth was both more complex and more troubling for German strategic planning. American aircraft production had indeed exceeded German estimates, but more significantly, American industrial philosophy had proven more adaptable to wartime requirements than German planners had believed possible. The decentralized, competitive manufacturing system that Germans viewed as inefficient had actually accelerated production through innovation and resource allocation methods that centralized planning could not match. Staff Sergeant Mitchell, tracking fighter attacks through his ball turret position, observed German tactical excellence that was undermined by strategic impossibility. Individual German pilots demonstrated skill levels that surpassed most American aviators, while their aircraft performance matched or exceeded Allied equipment in many categories. Yet these advantages were negated by numerical disparities that made sustained resistance impossible regardless of tactical outcomes. The human cost of this industrial disparity was becoming apparent to aircrew on both sides. German fighter pilots faced increasing pressure to achieve impossible efficiency ratios against growing American formations, while American bomber crews accepted casualty rates that would have been unsustainable without massive replacement capacity. The mathematics of industrial warfare were playing out in personal terms that reflected broader strategic realities. Thompson's aircraft approached its release point over the target area, joining a stream of bombers that extended beyond visual range in both directions. The formation represented industrial capacity that German observers found incomprehensible. Hundreds of aircraft operating in coordination over enemy territory, with escort fighters providing protection that seemed to include more aircraft than German intelligence believed existed in American inventory. The bombing run proceeded with mechanical precision that reflected both pilot training and equipment reliability. American bombers demonstrated consistency and accuracy that surprised German observers accustomed to early war performance levels. The improvement reflected not only pilot experience, but also technological refinements and maintenance procedures that ensured equipment reliability under combat conditions. As bombs fell toward their targets, German ground observers documented destruction patterns that confirmed American tactical development and industrial capacity. The ordnance represented manufacturing output that exceeded German production by factors that made effective response impossible. Each bomb had been manufactured using materials and processes that reflected American industrial advantages in raw material access, energy availability, and production efficiency. Hauptmann Weber, monitoring radio communications from multiple fighter squadrons, began recognizing the scope of the strategic challenge facing German defensive forces. The American formation represented more aircraft than his sector typically encountered in an entire month. Yet intelligence reports suggested this was merely one of several similar operations planned for the immediate future. The mathematical progression suggested American capacity that German production could never match. The return flight to England proceeded through German airspace that had been effectively neutralized by escort fighter operations. American fighters demonstrated both numerical superiority and tactical flexibility that reflected training programs and equipment availability beyond German capacity to match. The strategic implications were becoming undeniable. American industrial mobilization had achieved levels that made German defensive success impossible through conventional means. As Thompson's formation crossed the English Channel, German commanders began analyzing engagement reports that confirmed their worst strategic fears. The Americans had conducted a major bombing operation using aircraft numbers that exceeded German estimates of total American bomber availability, while accepting losses that would have crippled German operations but seemed to have minimal impact on American capability. The industrial disparity was no longer theoretical, but demonstrated through operational results that could not be disputed. Intelligence officers at various German headquarters spent the following days attempting to reconcile operational observations with existing estimates of American production capacity. The mathematics were inescapable. Either German intelligence was fundamentally flawed, or American industrial capacity exceeded all previous calculations by margins that made continued resistance questionable. Staff meetings that had previously focused on tactical improvements began addressing strategic questions that challenged basic assumptions about the conflict's likely duration and outcome. Captain Mueller's subsequent reports to the Air Ministry documented American aircraft performance and availability that contradicted every previous assessment of Allied industrial capacity. His analysis indicated production rates that German facilities could not match even under optimal conditions, supported by raw material access and energy availability that exceeded German capacity by factors approaching 5-to-1 in critical categories. The implications for strategic planning were profound and troubling. The Schweinfurt mission became a case study in industrial warfare that German military planners could no longer ignore. American formations had demonstrated both tactical capability and numerical superiority that reflected industrial mobilization beyond German capacity to match or counter through conventional means. The philosophical differences between German precision manufacturing and American mass production had been tested under combat conditions, with results that favored the American approach despite apparent inefficiencies that German observers continued to criticize. General Galland's post-mission analysis documented fighter engagement results that confirmed the mathematical impossibility of sustaining effective resistance against American daylight bombing operations. German fighter forces had achieved tactical success rates that exceeded pre-mission expectations, yet the overall strategic impact remained minimal due to American formation sizes that absorbed losses without mission degradation. The industrial capacity required to sustain such operations exceeded German estimates by margins that suggested fundamental miscalculations about Allied production potential. Feldwebel-Weber's maintenance reports documented equipment availability problems that were becoming critical as American operations intensified. Replacement aircraft arrived slowly, while spare parts became increasingly scarce, creating maintenance backlogs that reduced squadron effectiveness, despite pilot availability and training quality that remained high. The industrial support system that sustained German operations was proving inadequate for sustained defensive campaigns against American formations that seemed to grow larger with each mission. The strategic lessons from the October 13th mission extended beyond immediate tactical considerations. German military doctrine, emphasizing quality over quantity and precision over mass production, had encountered industrial warfare conditions that favored the opposite approach. American willingness to accept tactical losses in exchange for strategic persistence had proven more effective than German emphasis on minimizing losses through superior individual performance. The philosophical and practical implications were transforming how German commanders viewed the conflict's likely progression and outcome. Lieutenant Richter's personal combat report documented American fighter escort performance that exceeded previous intelligence estimates in both quantity and quality. The escort fighters had demonstrated aggressive tactics and numerical superiority that made effective bomber interception impossible despite German pilot skill and aircraft performance advantages. The engagement had clarified the strategic mathematics of industrial warfare in ways that individual pilot excellence could not overcome. The October 13th mission represented a turning point in German strategic thinking about American industrial capacity and military potential. Intelligence estimates that had provided reassurance about Allied limitations were replaced by operational observations that documented capabilities beyond German capacity to match or counter. The industrial mobilization that American democracy had achieved challenged fundamental assumptions about economic systems and their military applications that German planners had considered settled questions. Obergefreiter Kraus continued tracking American formations throughout the autumn of 1943, documenting a progression of increasing formation sizes and mission frequency that confirmed the industrial trends observed during the Schweinfurt operation. Each successive mission demonstrated American capacity that exceeded previous observations, suggesting access to reserves and production capabilities that German calculations had deemed impossible. The mathematical progression was becoming undeniable and strategically decisive. The aftermath of the Schweinfurt mission saw German strategic planning shift from offensive operations toward defensive preparations that acknowledged American industrial superiority. Military objectives that had seemed achievable with German technological and tactical advantages were reconsidered in light of American production capacity that could sustain losses indefinitely while maintaining operational pressure. The industrial mathematics of modern warfare had been demonstrated through operational results that could not be disputed or ignored. American aircraft production continued accelerating through 1944, ultimately achieving monthly output that exceeded annual German production across all aircraft types. The industrial mobilization that had surprised German observers in October 1943 represented only the beginning of American manufacturing potential that would ultimately prove decisive in determining the conflict's outcome. The philosophical differences between centralized precision and decentralized mass production had been tested under ultimate conditions, with results that validated American industrial approaches despite apparent inefficiencies that European observers had long criticized. And that concludes our story. If you made it this far, please share your thoughts in the comments. What part of this historical account surprised you most? Don't forget to subscribe for more untold stories from World War II. And check out the video on screen for another incredible tale from history. Until next time.